Hello, this video is on perpendicular lines. It goes with an overall learning target that says I can identify from equations and graphs whether or not two lines are parallel, perpendicular, or neither. So if you're watching this video, that means you are the one learning about perpendicular lines, and you'll teach your partner about this, and then your partner should be watching the video on parallel lines. So make sure you have the right note sheet and you are taking notes as you watch. So perpendicular lines are lines that intersect at 90 degrees, so they make a right angle, and the slopes of the lines need to be opposite reciprocals. So let's talk about what that means really quick. Opposite is talking about the sign of them, so they need to be opposite in sign, so one should be positive, one should be negative. And reciprocal means it's flipped, so like if I have maybe a fraction that says 1/2, the reciprocal of that would be 2/1. So I literally flip it and just switch what number is in what place there. In the graph, you can see here that slope is -4 for the one line, and this one is 1/4. So these are opposite sign because one is negative and one's positive, and then the reciprocals. So 4 would be the reciprocal of 1/4. Okay, so a couple things we have to practice. The first is recognizing perpendicular lines from an equation. So when I'm looking at parallel or perpendicular lines, so here we're checking perpendicular, the focus is always on the slope. So when I look at my first set of equations, I want to pick out the slope first. So the slope here is 3. It's a little hard to see there. Hold on. Right, that's it, 3. Don't know if that's much easier. And then we have a slope of -1/3 there. So I'm checking for two things. My slopes need to be opposite signs, so one needs to be positive and one needs to be negative, which it is. And then they need to be reciprocals of each other. They also are that. So this would be yes, these are perpendicular. Okay, let's check the next one. I can see my slope in the first one here. It looks like -2/5 is my slope. And then my second equation is in point slope form, which I can see my slope there as well. If you remember, the general form is y minus y1 is equal to m times x minus x1. So this is my slope in the second one. So if I'm checking those, they are reciprocals of each other, but they are not opposite signs because they're both negative. So those do not work. They are not perpendicular. All right, then we also have to be able to do this from a graph. So when we get a graph, again, we're just focusing on the slope of the lines. So if I look at this first one, I'm going to pick some points here. So I'm looking at this blue one. I would have to go, it looks like up 4 and over 2. So my slope is 4/2, which is the same as 2/1. And if I look at my other line, again, go from like here to right here, I have to go down 1 and over 2. So that slope is -1/2. So these ones are opposite sign. One is positive and one's negative. If I look at this, right, this one's negative, this one's positive, and they're reciprocals. So these are perpendicular lines. Let's check our second one. And I always tell kids, don't just assume anything, always check. So let's check our blue line. I have to go up 1/3, so it looks like my slope is 1/3. Pink line, I need to go down 2/1, so it's -2/1. Opposite sign, but they are not reciprocals, so that is not perpendicular. Okay, the next thing is being able to recognize perpendicular lines from two sets of points. So I'm giving you two lines here. Line A passes through 1, 5 and 3, 9, and line B passes through 2, -2 and 8, 1. So we need to find the slope of line A and then find the slope of line B and compare them. So let's do line A. I'm going to use the bar method. So if I'm looking at A, my slope would be change in y over change in x. So to get from 5 to 9, I have to go up 4. 1 to 3 would be 2, and that simplifies to 2/1. Let's look at b. I'm going to use the formula here. So let's try y2 minus y1 over x2 minus x1. And you could use the same strategy for each line if you wanted to. I'm just showing you some options. So that would be x2, y2. So my slope here would be 1 minus negative 2 over 8 minus 2. So this would turn into adding. So I would get 3 over 6, which is the same as 1/2. So let's double check these. I have a slope of 2 over 1, a slope of 1/2. So they are reciprocals, but they are not opposite signs because they're both positive. So this would be not perpendicular. And I'm just going to write PER for perpendicular. You can write it out on your sheet where you have a little bit more room. Let's try the next one. So again, let's do line A. My slope would be change in y over change in x. So 8 to 20, well, that would be going up 12. 1 to 5, I have to go up positive 4, so my slope is 3. For B, I'm going to rewrite it here so I have more room. 3, 0, and 9, negative 2. So here, 0 to negative 2, I have to go down 2, and then 3 to 9 would be up 6, and negative 2 6 simplifies to negative 1/3. So here I have a slope of 3 and negative 1/3. They are opposite sign, that's good, and they are reciprocals. So yes, this is perpendicular. All right, up next is writing equations for lines that are going to be perpendicular to a given line. So this one says it contains the point negative 3, 0, and it's perpendicular to the line that passes through negative 2, 4, and 2, negative 2. So we need to know the slope of this original line. So I'm going to find the slope here first of this original line. So that slope would be, well, 4 to negative 2 is minus 6. Negative 2 to 2 is 4. So that's the slope of the given line, is negative 3/2, but I know that I want to be perpendicular, like it says here. So that means my new slope of my line that's perpendicular needs to be opposite in sign, so it'll be positive, and the reciprocal, so I'm going to flip that. So it's going to be positive 2/3. And now I want it to go through this point, negative 3, 0. So I have a point and I have a slope. I'm going to put it in point slope form to start. Y minus y1 equals m times x minus x1. We have our x1, y1, and then we have our slope right here that we can plug in. So I'm going to have y minus 0 is equal to 2/3. In parentheses, it's me x minus a negative 3. So that is going to change to a plus 3. Now to graph it, we talked about the other day, changing this equation into slope-intercept form right away. To do that, I needed to distribute, and then I'll combine like terms. So I'm going to distribute this 2/3 through, so I get y minus 0 is equal to 2/3 x, and then 2/3 times 3, I'm going to put that over 1, is 6/3, which is 2. So plus 2, and then I'm going to add 0. So my equation is y is equal to 2/3 x plus 2. That's what I'm going to graph. So we had to go through a few steps here to get to that point. So now when I graph from slope-intercept form, I have to find my y-intercept first. Then I'm going to go up 2 and over 3. I can go down 2 and back 3 as well. And that would be my final equation. End graph. Okay, last example, similar to the last one. So I'm telling you I want you to be perpendicular to the line y equals 1/2 x plus 8, and you have to go through the point 8, 2. So I'm already telling you the original slope here is a half of this given line. I'm also telling you, though, I want you to be perpendicular to that line. So I have to figure out what my new slope should be because I want to be perpendicular to that. The first one is positive 1/2, so I know this one has to be negative, and then I have to do the reciprocal, so 2 over 1. So my slope is negative 2 over 1, or just negative 2. Then I'm also given this point here, x1, y1. So point slope form is going to be the best fit again. for us to use. I have my x1, y1, and I have my slope, so I'm going to plug it in. I get y minus 2 is equal to negative 2 times x minus 8. Now, I didn't say you had to graph, so you could leave your equation just in this form and be done. If you prefer putting it into slope-intercept form, we would distribute and get y minus 2 is equal to negative 2x plus 16. I'm distributing that negative 2 to that negative 8, and then I would add 2 here. So if you like having your equations in slope-intercept form, that's fine. This is what it would look like for that. Both answers are correct here. Alright, so you are now the expert on perpendicular lines. You're going to learn about parallel lines soon. So it's important to remember that two lines can be parallel, which you'll learn about from your partner, perpendicular, which we just went through, or neither. So if a line's not perpendicular, they're not parallel, then they're neither, and that happens. At this point, if you are done and your partner's not, please work on the practice review problems on the last 2 slides just to make sure you are still feeling confident with your other concepts. And then when your partner is ready, you guys will teach each other about what you just learned about.